Assalamu alaikum. This is 11th chemistry, and our today's topic is about these gas laws. Now, as far as these gas laws are concerned, these the behavior of the gases can be described by these gas laws, and these gas laws are of various types. We have got this Boyle's law. Now, as far as this Boyle's law is concerned, it was Robert Boyle in 1622 who studied the effect of this pressure on the volume of a given mass of a gas by keeping the temperature constant, and this relationship is known as Boyle's law, and it can be stated as the volume of a given mass of a gas. It is inversely proportional to its pressure at a constant temperature. Now we can also mathematically, this law can be put mathematically. As you can see, V is inversely related to pressure, so keeping this temperature and the mass of the gas constant, or we can write V is equal to K over P, where K is the proportionality constant, and or the product of pressure and volume is constant. So this K is the proportionality constant, and V it is the volume of the gas, and P is the pressure. Now as far as this proportionality constant, that is K, is concerned, it depends upon the mass and the temperature of the gas. Now if if we keep the volume of a given mass of a gas as it is in V1 as its initial volume, and having a pressure of a P1 at a constant temperature. Now if we now increase if the pressure is now increased to P2, then the volume will decrease to it will get decreased to P2. In that case, we'll write according to Boyle's law, we can write P1 V1 is equal to P2 V2, that is constant. Now this law can be, this Boyle's law, it can be also stated as the product, and that is the product of volume and pressure of a given mass of a gas at a constant temperature. That is, we can also define it as the product of pressure and volume. And that is constant at a constant temperature. Now experimentally, we can this law can be verified as that by measuring the volumes of a given mass of the gas at different pressures, keeping the temperature constant. Now in each case we see that the product of the two, that is pressure and volume, is found to always it is found to remain always constant. You can see that when the pressure, this is in bars, and this is this is the volume in decimeter, and this cube, and this is the product of pressure and volume. So when the pressure is it is 0.20 bars, in that case volume is 112.0, and the product of the two, it is 22.4. Now and when the pressure is increased to 0.25 bars, now in that case the volume gets reduced to 89.2, and the product of the two, it is 22.3. Now if we increase the pressure to 0.35 bars, in that case the volume will get reduced further to 64.2, and the product of the two, it is again 22.47. Now if we further increase this pressure to 0.40 bars, in that case we see that the volume gets reduced further to 56.25, and the product of the two, it is 22.50. Now if we further increase the pressure to 0.60 bars, in that case we see the volume gets reduced further to 37.40, and the product of the two, it comes 22.44. So we see in all these cases, that is by increasing the pressure, volume gets decreased, and but the product remains it remains almost constant, provided the temperature is kept constant, or the temperature remains same. Now, graphically, we can this can be represented as we have got volume pressure graph, as you can see here. This is we are taking this pressure along this x-axis, and volume is it is taken along this y-axis. So if we plot a graph between this volume and pressure, we will get a curve like this. In this case, we see, and this is the curve, and the temperature is here temperature is kept constant. You can see this is a curve. So this is at pressure, this is pressure P1, it corresponds to volume V1. Now if we increase the pressure to P2, volume gets reduced to P2. So this is a curve. This is similarly, we can see here these pressure volume curves at different temperatures. You can see here you have one curve at 200 Kelvin, then we have got 500 Kelvin, then we have got a 600 Kelvin. So different curves can be obtained at different temperature, at different temperatures, if we plot this pressure against the volume. Now we can see the nature of the curves is same here. You can see in all these curves which are obtained at different temperatures, the nature of these curves is same. The higher curve you can see here, which is at 600 Kelvin, it corresponds to higher temperature. However, the value of K, that is value of K, that is constant. It changes because it depends upon the because it depends upon the temperature. But the curves plotted at these curves, which we get at constant these constant temperature, we get, you can see I have shown here there are three different curves. So these are called as isotherms. Now we can also plot this volume against this reciprocal of pressure. Now, so this is volume reciprocal pressure graph. Now Boyle's law, we can see it can be also represented by plotting this pressure versus this reciprocal of the pressure. Now the graph is, you can see it is a straight line which on extrapolation it can pass through the origin. So this shows that volume is here. If this pressure is plotted against this reciprocal pressure, then we get it is a straight line, and this shows volume is directly proportional to the reciprocal of the pressure. Again, we can see here, you can see if we plot this pressure volume, that is product of pressure and volume against this pressure. In that case, here you can see as the pressure increases, PV, this product of the pressure and volume, it remains constant. This is constant. So you can see here, this is a straight, we get a straight line here. You can see this product of pressure and volume, it remains constant at temperature T1. Similarly, this is again a straight line. You can see here, that is the product of pressure and volume. It remains constant if we increase the pressure. This is at temperature T2. Now you can see that as the temperature increases to T2, this product of pressure and volume, it gets increased. Now as far as the importance of this Boyle's law is concerned, this Boyle's law, we see that when a given mass of a gas is compressed by increasing the pressure, the volume, we see it gets decreased, or volume decreases. That is the number of molecules per unit volume increases, or we can say density gets increased. So at sea level, we see pressure is 1 atmosphere, and air is quite dense. That means the density is more. However, at high altitudes, and this pressure gets decreased, or pressure is less, and volume of the air is it is more, that is density becomes less at high altitudes. So it is for this reason that we can see that at high altitudes, where got the concentration of oxygen is in air is insufficient for normal breathing. So that is why mountaineers, they carry these oxygen cylinders with them when they go for mountaineering. So this is for today. Thank you very much.